Alright, so before we proceed to our new concept for today, or new mathematical concept for today, please don't forget to subscribe and then push or click the notification button for more videos. Teacher Dong. Alright, so let's start. We will now be having direct variation. So, but before that, what is variation? Variation is the change between the two quantities, or the relationship of the changes between the two quantities. So it's from the word vary, means there are changes. Alright, so but before that, let's recall the following. Let's start with first with a constant. A constant is a quantity whose value does not change. Example, 0, 2, and pi. Right, so pi has a definite value. Then variable is a quantity whose value is changing. We can use all the letters in the English alphabet except O. Why not O? Because, okay, so it might be mistaken as 0 if you will be using it. Let's start with the first type of variation, which is the direct proportion or direct variation. So for variables x and y and the constant k, if the ratio y over x equals k, then y is directly proportional to x, and then y varies directly as x. In symbols, the equation that we will be using here is y equals kx. Remember that the problem falls under direct variation if you will be seeing the statements varies directly as or is directly proportional to. So where k is the constant of proportionality or variation. So what is the relationship between the quantities here? If the first quantity increases, the other one also increases. That's why we call it direct variation. So if the first quantity decreases, the other one also decreases. So what is the best example? If we're talking about the price of a gasoline and the fare in the public utility vehicle. So if you are going to observe, if the price of the gasoline is going up, okay, so what will happen to the price of the fare? So the price of the fare will go up as well, right? So but if the price of the gasoline goes down, okay, so I don't know if the price of the fare in the jeepney or any public utility vehicle will go down. Okay, so it's up to them. All right, so that is the best relationship that we have. Okay, or that is the best example. Next, example 2.1. Write the equation for the statement A varies directly as S. Okay, so we can easily actually identify it easily as direct variation because of the statement varies directly as. So we can now actually write the statement or equation. A will be equal to the constant of proportionality times S, wherein S is our independent quantity and then A is our dependent quantity. Alright, so that's it. Next, that's how you are going to write in equation. Write in symbols the area A of a circle varies directly as the square of the radius. Alright, so please make sure to identify the two quantities that are being compared. Okay? Right, so the first is area of the circle and the other one is the radius r, or square of the radius r. So first things first, the dependent event will be the area equals the constant of proportionality times the square of the radius. So it will be like this. So this will be the symbol. Next, if y varies directly as x and y is 15 when x is 3, find y if x is 5. So this is the varies direct variation because of the statement varies directly as, and then we have two quantities y and x. So first things first, we have to write the variation equation, which is y equals k times x. Alright, so in this manner, we are looking for the value of y using three values. The first value of y, which is 15, and then first value of x, which is 3, and the second value of x, which is 5. First is we can actually write the first direct variation symbol or equation using the first values. So it will be now 15 equals k times 3. Then the other one is y is unknown equals k times 5. Alright, so the first thing that we have to solve here is the value of k so that we can solve the value of y. We will be using the first equation, always the first equation in solving for k, or the constant of proportionality. Alright, so 15 equals k times 3. Divide both sides by 3. K will be equal to 15 divided by 3, 5. That's not yet the final answer. We need to solve for the value of y. So in solving for the value of y, we will now be using the second equation. Substitute the value of k. Y equals the value of k, which is 5 times 5. Therefore, y is equal to 5 times 5 equals 25. So the value of y is 25. This will be your answer. Try to observe the values of y. The values of y are 15 and 25, and the values of x are 3 and 5. So from 15 it became 25, so therefore it goes up. From 3 it became 5, so therefore it also goes up. So what does it imply? It implies that, okay, if the first quantity increases, the other one increases. That's why it's the best example of a direct variation. Next example. Example 2.4, the diameter d in centimeters and the circumference c in centimeters of 8 circles were measured and tabulated as follows. So the diameter, we have 2, 3, 4, 5 until 9, and then for the circumference, we have 6.28 until 28.26. Just remember that the circumference here is our dependent, and then the diameter is our independent. Why? Because the value of the circumference depends on the value of d. Alright? So as you can see, the relationship is that as the value of the diameter increases, okay, the circumference also increases. So this is a direct variation. So as you can see in the graph, if you will be plotting all the points, okay, the graph goes up. So therefore, it's an example of direct variation. Next, what is the constant of variation? So in solving for the constant of variation, we can use this, and we can use all, but we will be using only one. So 2 and 6.28. First is write your variation equation. C equals k times the diameter. So the first value of C is 6.28, and the value of D is 2. K times 2. Right, so divide both sides by 2. K will be equal to 6.28 divided by 2 is 3.14. So if you are going to observe, 3.14 is also the pi. Why? Because we're talking about the formula for the circumference of a circle, which is pi d. Alright, next, write an equation for C in terms of d. So that's it. It's the formula for the circumference of a circle. C equals pi d. Then what is the value? What is the value of C when D is 10? Alright, so we will be using C equals pi D in solving for the value of C. C will be equal to pi times the value of D, which is 10. Alright, so multiply. So this can be 10 pi, or the other way around, you multiply 10 times 3.14 as the approximate value of pi. So we will be getting 31.4. Next. Example 2.5. The force required to stretch a spring is directly proportional to its elongation. If a 24 pound of force stretches the spring in 3 inches long, what force is required to stretch the spring 6 inches long? So if you are going to observe this one, okay, so we have to first identify the two quantities. So we have the force, and then we have the elongation, which means the length. Alright, so it means that according to the problem, as you actually stretch the spring, okay, you are required to exert more force. Alright, so that's it. First thing that we have to analyze here is to identify the unknown value. The unknown value is the force. Okay, so therefore we will be representing force to F. So let F be the force. Right, so next thing is we have to write our variation statement. So force is directly proportional as the elongation. We can represent it as L because it's the length. So F is equal to K times L. Right, so let's write the first variation equation using 24 pound for the force and then 3 inches for the elongation. So force is 24 pounds equals K times the length, which is 3 inches. Alright, so this will be our first variation equation. Next is force is unknown. F will be equal to K times 6 inches long. Right? So first thing is we have to solve for K using the first equation. So 24 pounds equals K times 3 inches. So divide both sides by 3 inches. K will be equal to what? So 24 divided by 3 is 8 pounds over inches. Right? Next, let us now solve for the force. Using the second equation, F equals K times 6 inches. Substitute the value of K, which is 8 pounds over inches. Okay, so 8 pounds times 6 inches. Multiply, what is 8 times 6? 48. So the force required for 6 inches long elongation is 48. Alright, cancel the inches because the unit of force here is pounds. 48 pounds. So this will be our answer. Next, last example. The velocity of a falling body varies directly as the time of flight. So the two quantities that we are talking about here, the velocity of the falling body and the time of flight. So if the velocity of the falling body at the end of 2 seconds is 64.4 feet per second, find the velocity at the end of 5 seconds. So first thing is we have to find if what is unknown. The unknown value is the velocity. So we can represent V. We can represent velocity as the V. So let V be the velocity. Alright. Next, let's form the variation statement. The velocity varies directly as the time. So V equals K times T. So let's form the first variation equation. So first is we have the velocity of 64.4 feet per second equals K times the time, which is 2 seconds. Then for the second one, the velocity is unknown, equals K times, alright, so 5 seconds. So always we have to solve for the K. Using the first equation, 64.4 feet per second equals K times 2 seconds. Divide both sides by 2 seconds. Okay, so K will be equal to 64.4 feet over square second. Then let us solve now for the velocity. Alright, so using the second equation, V equals K times 5 seconds. Substitute the value of K, which is 64.4. No, the value of K we still need to divide. 64.4 divided by 2 is equal to what? 32.2. So I'm sorry for that mistake. Alright, so this will be 32.2 feet per square second. Right, so substitute 32.2 feet per square second times 5 seconds. Cancel this will only become S. Alright, next, multiply what is 32.2 times 5. So it will be 161. The velocity is 161 feet per second. So this will be our answer. So that's it. Okay, so those are the different examples that we might encounter under direct variation. So it is direct variation. If the problem is direct variation, just simply look at the variation statement. Varies directly as or directly proportional as for you to be able to use the proper equation. Alright, so thank you so much for watching. Okay, so I do hope that you have learned a lot. Don't forget to subscribe and click the notification button. Again, thank you so much. This is Teacher long.